Hello everyone. Sorry it's been a while since I've made a video. I've just been really busy with a lot of other things other than programming, life, and work. But I have been working a lot on my book. I got it up on my website. It's not finished. I'm just trying to get it up there in preparation for it being done. But I'll give an update on this in the next video. So this video is Hare 0.26.0 was just released yesterday, and I sat down last night to start making a video. I wasn't able to finish it, and I saw this came up, so I wanted to go ahead and cover this. So go ahead, and if you go to the blog section, I think this is also on the main page. And let's just go ahead and go over this. There's a lot of quality of life improvements. These are mostly what they highlight here in the blog are a lot of really interesting features they put into the language. You can see it is compatible with Cube version 1.2. And here are the release highlights. So loop values for and for else. We'll look at that. That's right here. DragonflyBSD support, so that's really cool. Explicit syntax for ignoring errors when needed. I'll show you what that looks like. Kind of like in Go is what it kind of looks like. So we have this this new feature to pad structs. So replacing offset, this is an attribute. With fields, it's an underscore for padding structs, and support for explicitly uninitialized variables. Now normally you have to initialize every single variable when it's created, but as they point out here in the blog, there are some times when that would be helpful. So loop values and for else. So Joe Finney designed and implemented another change to for loops in Hare that's included in this release. They can now be used in expressions to compute a result other than void. There are two ways to supply a value to serve as the result of a for loop, using break with a value and adding an else branch at the end of the loop. You can see if the loop ends via break, so right here, the value you give to the break expression is used as the result. Otherwise, if the loop completes without producing a result, the else branch is used. In this example, we could have used yield default value or something similar in the else branch to provide a value to assign to item, which is right here. But instead we just print an error and return. So the else branch has the type never, and that's because it's using the return keyword, which returns type never. So I'll just give a quick demonstration. You can look and see exactly how this is working. Now I don't have a key value pair. You can see if I say Hare version, you see I already have 0.26 installed. But if I say what we can do is I can just make a call it items, and let's just make it an array of ints and just random stuff here. We'll do 13, 25, 33, 47, and 52. Looks good to me. So now how we use this, so we want to, from a for loop, we want to assign a certain value back to a variable here. So I'll use a let binding, and I'll just call it A. Very creative. Okay, so this is a for each loop. So let I in items, and then what we would say is if we'll say I equals, let's find one of these. We'll do 47. Okay. What we'll do is break, and then that's going to return I, and then this is going to be our else branch, and we'll just say, now they use this error format line. I don't have the key value stored. Let's say error line, and we'll just say item not found. Okay. Now, and I'll go ahead and show you since we're here. So DragonflyBSD support, that's really cool. There's nothing else that I can cover about that here. I don't have DragonflyBSD on my system. I am on I'm on Alpine. I had problems with Debian with the firmware. My computer's too new, even in backports. It was just with the ACPID and everything. It was just my fan was spinning constantly, and so anyways, long story short, I don't have DragonflyBSD, but that's supported. Here is this part here, ignoring errors. And you see this looks like a lot of other languages have this feature when you want to ignore a value. Now, in Hare, maybe they'll think more about some features around this or some syntax, because at the moment you can only use this alone to ignore an error. Okay, so this is what it looks like. It's an underscore. So if I wanted to ignore the error from, let's say, print line, okay, and what are we printing? Our a value, okay. Now you see normally you would have to use the error assertion flag, or you would have to match on this, okay. So we have our for loop. Now I'll admit the syntax for this gets to be, I don't know, a little clunky, I guess. It is what it is. So let's go ahead and run this, and what's actually going to happen is this is going to return this value to our variable here, okay? So can't ignore error here. Let's go ahead and just use that feature here too. Might as well, right? Now, and the thing about this is when you use this feature, you can say this makes the fact that you're ignoring the error more explicit, and it does not raise an assertion. Okay. If an error occurs like the error assertion operator would, it just proceeds normally. So that's pretty cool. Okay. Use this wisely. Okay. If you have an error that you need to handle, then don't use this. And you can see it returns 47 back to our value. Okay, that's right here. Now let's say I'll just put something else, right? That's not in our items array. So what's going to happen is the else branch is going to run, and we're going to get this error printed out to standard error, because as you can see, this prints to standard error, right? The standard error stream. So let's go ahead and run this. Let me clear my screen. And you can see item not found, and it returns void, because that, by default, that's what this expression will return. And that is why, that's the whole point of this right here. That's the whole point of the break, and then you can supply it with a value, okay? So that is this little feature. Okay, that's the they're calling it the for else, and then DragonflyBSD support, ignoring errors. Okay, now this you can pad structs with basically the same thing here. It's an underscore. So what I wanted to say, I was thinking, you would think that you could do something like that, right? And you could capture the return value, but then also ignore the error. Okay. I don't think I've tried that yet. I'll just name this B, really creative. Oh, we already have an A. This will be B. see. Like you can do this in Go. This is like classic, Go is to when you want to ignore something, and also in a lot of other languages. Um, I don't think it's going to let us do this because this is a tagged union. It's not a tuple, right? It's not returning two values. These functions, they're only returning one value at a time, okay? But let me just see what happens. Yeah, see, we're not able to do that. Um, that would be kind of cool, right? If you could capture um, the result value and then ignore the error case. That would be kind of cool. Um, but at the moment, I don't think you can. It's just the only way that this works is if you just ignore the error. Okay, but if you need to ignore the error and capture the result, there I don't think there is a way to do that. It doesn't appear there is. Okay, so that is that. Um, Let me go ahead and remove that and just make a new file, and let's go ahead and look at these features here. So you can pad structs, and this is when you use the packed attribute. Now, if you're not familiar with struct padding, I'll explain what it is. Okay, so another use of the underscore token was added in this release. The ability to add unnamed struct fields for the purpose of adding explicit padding. Previously, one could use the offset keyword. This is an attribute, anything with the ampersand, excuse me, the at symbol, to explicitly define the offset of your struct fields, but this was quite labor intensive and cumbersome to use and required a pretty complicated implementation. Joe Finney, thank you Joe, improved the situation for this release, and now one can simply define nameless fields using the underscore. So the way this works is, let's go ahead and let me just copy this. Okay, just make it easy. Okay, so now we have a struct name, my struct. Let's call it one. And okay, so this is at offset 0. This is at offset 4, and this is going to be at offset 5. Now, you can see this struct is packed. Now let's look at, let me create the same thing, except I'm not going to, except let's have this struct not be packed, okay? And let's go ahead and all we're going to do is, let's use our little feature here, and let's print the size of 1, and let's call this 2, and I know, really creative, right? Okay, so what we're doing here is, this is a pack struct, this struct is not, and this is a padding specifically. In this case here, you wouldn't really need a U8 padding in that scenario. Now what's going on here, because this keyword is highlighted, but this is not right here. It seems there's some sort of parsing error with the syntax highlighter. Interesting. So let's go ahead and run this and look and see what happens. Okay, so you can see 13 and 16, right? Exact same struct, or exact same struct members, but one is packed and one is not, okay? And the reason for that is because of the offsets of these, right? So say, okay, let's use, let me try and give you a more clear example of what a regular struct would be. So let's say we had a U8, okay, and then let's say we had a U64, and then let's say we had a U8, okay. Now, what's going to happen here, and you see this is not packed, so this has the packed attribute, but 2 doesn't. So this is still going to take up 8 bytes, just like U64. This is only 1 byte right here, okay? This is 8 bytes, a full 8 bytes. Again, this right here is only 1 byte. So looking at this struct, you would think that this is going to be 10 bytes, right? Because you have 8 plus 1 and 1. Let's see what happens. We're looking at the second print line statement. Let's see what happens when we print this struct here. And you can see it's 24 bytes, okay? So that is that this struct is not packed. And the reason for that is because of the alignment, okay? This is taking up 8 bytes, even though it's 1 byte, it's taking up 8 bytes, okay? And so that's the difference between a packed struct and one that's not. And this has to do with, you know, optimizing for, when you design a struct, okay, you want to try and optimize it for your data layout, right? So what we could do instead, right, is say this, and now what's going to happen here is this is only going to be 16, okay? And you can see it's only 16, and that's because what's happening here is you have 2 bytes, and then this is padded with 6 bytes, okay? So if we wanted to, now it's doing this automatically because it's a non-packed struct, right? But we could, if we wanted to maintain the proper data layout, okay, we could pack this, well, 6 bytes. Okay, so you would pad this with 6 bytes. Okay, how you would go about that, and then you would also need U8 or U16, right? But the point is, that's what a pack struct is, and you can use this to provide additional padding in your struct. And I don't think it has to be a pack struct in order to do that. I think you can just use this feature um, in any struct, even if it's not packed, okay? So now let's look at explicitly uninitialized variables. Until this release, Hare has required all variables, locals and globals, to be initialized at the moment they are defined. You're probably familiar with that. This is almost always the right thing to do, but sometimes it is useful or even necessary to declare a variable without initializing it. If you pass a pointer to a variable into a function that will initialize it for you, for instance, you might have to initialize it with a meaningless value in order to fulfill that function's contract. This gets worse if the type does not have a default value, such as non-nullable pointer types. When the object they will ultimately reference does not exist at the moment of their declaration. Drew DeVault fixed these issues, thank you Drew, by allowing one faced with such a scenario to explicitly initialize the variable, and you see initializes in quotes, the variable to undefined. Now here's where we start to introduce some, now I'm not an extremely experienced systems programmer, okay? And if the language designers feel this feature is necessary, I'm going to take their word for it. But you can see we've started to introduce some, I don't know if I would call this undefined behavior just because the word is undefined, right? Because that's technically not what undefined behavior is it means it's not defined in the standard, right? But this does start to introduce some things where you can kind of get in trouble. So one can initialize, see in quotes, the remaining fields of a struct to undefined. And this is an example of that. Okay. Now, so let me show you, okay, let me show you what will happen if, say we try to do, um, say we try to initialize just a variable to undefined. There's nothing going on here. The compiler doesn't know what this is. Okay, there's no size. There's nothing associated with this to tell the compiler what the undefined value should be. Okay, so when we try and run this program, you can see you cannot create binding for type of undefined size. See, the compiler doesn't know what that is, and rightly so. There's no way to fix that, right? You would have to put some type of type annotation here. Okay. Now let's look and see what happens if we try to print this value. Okay, because this is uninitialized. This is an uninitialized variable. Okay. And you can see this right here is actually coming from QBE. Okay. And so, as you can see, the programmer is then responsible for ensuring that the variable is not read from until it is initialized later on. So this is what I'm doing here. Okay, we're reading from this variable that's undefined. So you are responsible for ensuring that you don't read an undefined variable, or else that's what's going to happen. Okay. The default behavior remains to require initializers, since that is almost always the correct way to write your code, but another escape hatch is available now for use cases where the programmer should verify the correctness of the program without the compiler's help. And I would say, I think this is where I think some non-professional, you know, Rust people get things mixed up, because I think if you would ask the vast majority, who I think is honest, systems programmers, there can never be a such thing as a completely safe systems language. When you're interacting with memory and hardware, there's just people have tried. Cyclone was really the first kind of C dialect to try and do things around memory safety and things like that. And you have things like the ComCert compiler that tries to verify C programs formally. But the point I'm trying to make about this feature is there is no such thing as a safe systems language, right? A lot of that I think would really have to be implemented at a hardware level. Okay. And there is a project, Hare, that aims to do that kind of thing, and they're trying to create an entire open source desktop ecosystem. So, while this does introduce a little bit more danger into Hare, um, this is something else that the programmer is going to have to watch out for. I showed you here in this example, if you try and read from this variable, it's going to give you an error from the backend, from the cube backend. Now let's say we had or let's call this this will be a student, right? And we have a name and an ID. Okay. Now let's say let's student one equal a student, and let's say let's undefine everything. So everything is undefined, okay? And now let's ID. Now let's see what happens. Okay, now everything is undefined for this struct right here, right? I think I actually have to make this a string, and let's make this an int. Okay, so now this struct is undefined. You can see the language syntax is highlighter's having a little bit of trouble with this. It thinks this is a def keyword, you know, like when you define a you know, you'd say def instead of let or const. So it seems like it's having a little bit of trouble determining what that is. That's not going to affect how the program runs, though. So now let's see what happens. We've technically not initialized the struct. It's undefined, and we have a string value and an int value. And we're reading each one of these, and I just realized this. Okay, so now let's run this. Unknown attribute. Oh, undefined. I missed the D at the end of it. Okay, so undefined. But you see, this time we don't get an error. Okay, so we have an empty string and it's initialized to 0. Why that happens, I'm not exactly sure. I'm not sure why. For example, you know, you can have this be undefined. You know, I think that's because this right here is initializing everything to their default value. Okay, I think that's what's going on. So if I were to remove this and I were to say, if I were to say name equals undefined, right, and then if I were to say ID equals undefined. Now let's try and read this. What did I do? I see. Let me just remove this. I didn't have a semicolon at the end of it, but we don't need that anyways. Oh, and you can see we definitely, yeah, see, illegal pointer access. Okay, and we get a backtrace. So yeah, so don't do that. Yeah, so right, point taken. You cannot read from an undefined variable. What this is doing here with this syntax, see, I guess you would call it, you know, technically an ellipsis, but the 3 dots is it's sort of default initializing these, I guess. I don't know. It's hard to say. That's weird because um, if I were to remove this and just have the, you know, just the 3 dots, it's the same exact thing in this instance. So, you know, I love playing around with this language. I love trying to break things and seeing how stuff works, you know. So this is definitely something that, you know, these are definitely features I'm going to have to start digging into a little bit more and learning the semantics around them and how everything works. Okay, but I wanted to cover that. So Hare version 0.26.0 is out. If you want to update, go ahead and update. I do have a video on my channel if you need help installing Hare. So like if I look for, so for me, let me just find, so, uh, so you can see, okay, so Hare's right here, you see, where is it, Hare C and Hare. Here's Hare C, here is Hare. You see in the Alpine repos, it's still just 25.2. And besides, the way Alpine works is it's on 6-month cadences, and I love Alpine for that reason, right? Because they have stable packages for 6 months. Um, but the point is, want to um, if you want to update to 26, you're probably going to have to bootstrap from source. Let's check Edge, okay, and see and see. Okay, look, so Alpine Edge, so the Edge branch here, it does have 26. So if you're on Edge, which some people like to run this, I don't, I just like a little bit of stability, you can get 26. So 26 is already in Edge. That is crazy. This was just released yesterday, okay? So, Simon Zenny, you're awesome. He's they already have 26 on the Alpine Edge branch. That's just crazy. It was literally just released yesterday. Okay, today's Saturday. It was released yesterday, Friday, and they already have 26 in the Edge branch. That's impressive. I think this is an automated build, so maybe that's just how it works. You know, when a new update comes, it's a there's a script or something that automates the build. I want to dive into Alpine packages more and maybe build a couple. But anyways, so that is Hare 0.26.0. Thank you to all the maintainers and everyone who made this happen. Um, so yeah, and I will work on getting out the next video in the tutorial series as soon as possible. I might have time today to do that. If not today, definitely tomorrow. So I appreciate your patience with that. I've just been really busy with all kinds of things. I wish I had more time to do more videos, but I don't really. So, so anyways, that is Hare 0.26.0, and go ahead and update if you want to. And you can see they actually have tarballs here, okay? So they have released tarballs, which I think this might be the first time that I've seen those actually. Um, I don't know if they've ever released tarballs before. Now this tool here, Hare Update, this helps you update your previous code, okay? Um, so this is the compiler and the standard library, okay? And so if you just needed to do a quick little install, you can grab these tarballs right here. So that is Hare version 0.26.0. I really appreciate you watching, and I will try and get the tutorial series out as soon as I can. Thank you so much. Have a nice Saturday, or whatever day you're watching this.